Mr. Akash Kadam. Mr. Kadam is a mechanical design engineer with end client Caterpillar in the USA, specializing in developing advanced supply chain and smart manufacturing solution with the framework of Industry 4.0 and 5.0, leveraging AI, machine learning, big data. Akash has over a decade of experience in driving innovation in digital manufacturing. He holds masters in mechanical engineering from Texas A&M University, USA, and has authored 5 research papers with 3 additional work accepted. All highlighted his expertise in smart manufacturing and supply chain management with the Industry 4.0 and 5.0 paradigms. Akash has also developed a pioneering solution that automates manufacturing scheduling using AI and machine learning. Today, Mr. Kadam will take us through AI, ML, big data for supply chain and smart manufacturing. So please welcome Mr. Kadam.
Thanks, Vivek. Let me go ahead and share my screen. Supply chain and a little bit on the smart manufacturing. A little bit about myself. I work as a senior design engineer for the Caterpillar. I got almost more than 10 years of manufacturing. To get some background on it, the AI is like simulation of a human intelligence by machine. Something like human can do, the same machine will do, but with a more speed, more accuracy on it. The machine learning is kind of programming that can learn from itself or the data and improve the performance. Big data is kind of all kind of data like supply chain, part number, part quantity, or the manufacturing, CNC machine data, everything that can be analyzed and used with AI ML, and we can do a magic there. So the role of big data in the supply chain and manufacturing, I would say the big data, the data is really critical for any kind of application that we're looking at the supply, the industry 4.0. Is 4.0 is all about the data and everything. The key source for data collection would be IoT devices for the real-time monitoring. We know the farmers already using it to monitor all their products coming to them or going from them that needs environment, climate conditions. The ERP systems, almost every industry use those ERP systems right now. There's all kind of data in there, or the sensors that can capture all kind of data for us. In kind of manufacturing, I would say all the machining performance and everything we can get through the sensors and inform the increase the efficiency of the machine. So the data's application could be demand forecasting, inventory optimization, or real-time tracking. As other guest has touched base this point, I don't want to spend more time on this. I'll go to the next slide. If you want to go and look, the article is already published, is a free access. Or if you want to touch base with me, you can send me an email, and I can volunteer and get your inventory management on a track. The system works like the first thing is data collection, data preparation. This whole kind of data here is part number, part quantity, and the critical level that we need to decide, or engineers who work on that part. Then we have to create a dashboard on the Power BI. Power BI is the free tool you can use in the industry that can, and we have to create a connection in the Power BI of different kind of data there. And with the logic behind this dashboard, run a flow and refresh your memory every day in the morning. And if the critical value goes below your current inventory, it sends email to a particular person and asks him to check his supplier, what's happening when they're shipping the part, or if your line going to be down for that particular part, and we can take action before a couple of weeks. That's the logic here. To it's kind of bin system, but bin system is manual tracking. If you see a small scale, medium, and large, small and medium scale has manpower issues, and if you go for the large scale industries, they have thousands of parts. Even they have the manpower there, is really critical to manage every single part. So this is where it comes into play. Everything is automated here. You just have to identify the data coming to the system. Predictive analysis, we can, based on the data coupled with AI and the machine learning, we can decide the demand trend, what's happening in the market, and what product can be released and what will be profitable for us, or the potential disruption in the supply chain. Any kind of man-made or natural disaster, it can be found through the applications, and they can let us know. If you having the having the material coming from that particular area, we'll be able to know what's happening there, and we can get some prevention actions done. And then supplier performance. Every company has multiple suppliers. It's hard to track every single supplier together. So with this application, every single supplier's performance can be tracked, and every single supplier can be treated differently. Then another one is dynamic routing and scheduling. The one thing I consider, like, if we have like 10 suppliers and we're getting material from 10 different routes, why not just schedule one route that line up with all the 10 locations and pick up at one day in a week, get your own pickup truck and move those 10 points and come back to your location. That saves your cost, that saves your carbon emission there. Then the warehouse automation, we already start seeing some robots coming into play and picking, packaging, inventory management, everything there. And it also increases accuracy and reduce labor cost. If P models, we just heard the importance of the data here. So what does this model do? It extract all the data from the emails, then it could be used to formulate the email responses to improve relation or identify performance of supplier. So at this point, we have almost 90% data on the emails. And this model will help to tabulate the data on the supply chain, what part coming to the what date, what was the ship date, and how many parts we getting. All kind of data is an email, and then that was extracted to the Excel, and then we can use this for any kind of dashboard or any AI application here. This model can be used on all the sensor output or all the machines in the workshop that can pull the data from it, and we can use it in an Excel sheet. So it's a less human work on extracting the data. And the guest explain the predictive maintenance, process optimization, quality trace, or the CNC machine. Most of the things goes for the tool. So we can implement the sensors to get the data from the tool, the temperature, or even the inspection data on the last part, how it's coming up. Based on that, we can identify if the tool need to be changed, or how's the life on the tool, or if there is a maintenance needed before it breaks down. Even if it, you should know by now about the CNC, the tools break down, the whole material is waste on that part. So we can prevent that kind of thing with these applications. For the process optimization, AI can be used on the line, consider assembly line, to improve the optimization or improve the efficiency of the line. Considering we have the assembly line of 10 different spots, if some AI can predict what's happening at the next, or it can analyze all 10 spots at a time and let the operator know what to do. And the quality control, one of the things I was working on getting a AI application done for the brake press machine, where they can find the flange length of all the form part and let the operator know if there is any change on the setup or not. So based on that, it kind of inline inspection done, and you don't have to spend a lot of time at the end of operation or at the end of product. That's kind of application in a smart manufacturing. They will come up early next year, but I would like to touch base on the application that was designed. It was implementing a Industry 4.0 and going towards the Industry 5.0, considering the human-centric approach here. The application is designed that schedule everything and control all the operation in the manufacturing shop, starting from the estimation, inventory management, and the workload scheduling. The machine learning operation, what it does, based on it takes all the time required for each machine and update the timing for the estimation, so that we get the actual numbers there. The inventory management, once the job comes to the factory, it run a check for all the inventory that we have, and what we don't have, it let us know from what supplier we need to buy it based on all the data we have. And the workload scheduling, like how much job we have and which machines are open. Based on that, and of course the shipping date, based on all the information we have, it will schedule every single job for each machine. We'll probably see this out by early next year. It's kind of more human-centric approach, all we're doing right now is Industry 4.0 and evolving to the 5.0, from data to the AI. So all the application will get the data, use it, and it gives all the information to the operator and let him know which one will be the best decision, and then the human can make a decision based on all the AI information. And then the personalized supply chain. This is the best thing. It can treat every single supplier as separate, and it can get the data from A to Z and let us know how the supplier is and what we have to do to improve the supplier or their supply chain. And the sustainability integration is kind of reducing the carbon footprint that I just talked about, in lining our all the supplier location and everything. That will be a great thing with Industry 5.0, all with the environment and everything. It can be done through that. And that's all I would like to present here.